Hi guys, we are back with part 2 of the review for checkpoint number 4. So we are picking back up at properties of polynomial functions. So all functions can have specific properties that can be used to describe them, and we're going to discuss some now. We've got x-intercept. X-intercept is a point on the graph where it touches or hits the x-axis. It does not need to pass through the x-axis. It can just touch the x-axis. We've got two of them here, one here and one here. Two x-intercepts. They're written as points x comma y, where the y value is always 0. So there are two x-intercepts in the graph here. They're at 0, 0 and 2, 0. We also have y-intercepts. Y-intercept is a point where the graph touches or hits the y-axis. It is written as a point, x value comma y value, where the x value is always 0. So unlike an x-intercept where the y value is always 0, in a y-intercept, the x value is always 0. In the example we have below, we have a y-intercept here on the y-axis, and it's at the point 0, 2. For increasing or decreasing intervals. An increasing interval is an interval on a graph denoted, and this is important, by x values, not y values, x values only, that states where the graph is rising or going up as you move from left to right. A decreasing interval is an interval on the graph, again denoted by x values, where the graph is dropping or going down as you move from left to right. Graphs can have more than one increasing or decreasing interval. So we have an example here. It says, given the graph below, find the increasing and decreasing intervals. So we're going to do that here. What I'm going to suggest is you make a number line, okay? You make a number line below your graph. Like so. And on that, you are finding the highest and lowest points, the relative maximum and minimum points, which we're going to talk about in a second. And we're going to put those x values on the number line. And that is going to give you the places where it's going to change from either increasing to decreasing or decreasing to increasing. If you look here, for this section, as we go from negative infinity all the way to this relative maximum point here, we are going up. So therefore the function is increasing. Then from this relative maximum point here to this relative minimum point here, our graph is going down. So we are decreasing. And then finally from, again, this relative minimum point here all the way to the end at infinity, the graph is going up. So we are increasing. And what you want to do, again, we're using the x values of these points to find our increasing and decreasing intervals. So our increasing intervals, there's two of them, here and here. And the x values are from negative infinity to negative 2. That's this part, or this part. And then from 0 to infinity, this part or this part. And then there's one decreasing interval from here to here. And it's going down here, -2 to 0, here, -2 to 0. Again, x values only. Super important, x values only. Then, last thing we're going to talk about are relative minimum and relative maximum points. I actually mentioned them just a minute ago, talking about increasing and decreasing intervals. A function has a relative minimum when that point is the lowest point in its general area, and a function has a relative maximum when that point is the highest point in its general area. There can be more than one relative minimum or maximum, or there could be none of either, or none of one and one or two, doesn't matter, depending on the function. So these relative minimum and maximum points are based upon, again, not necessarily the highest and lowest points in general, but the highest and lowest points in their general area. So we have the example here, given the graph below, state the relative minimum and maximum points. We only have one relative minimum. It is this point right here. It also happens to be the y-intercept, but that is not always going to be the case. But it's a relative minimum point because it is the lowest point in its general area. And it's always written as a point, x comma y, so 0 comma -2. And relative maximum, in this case, there are two of them, here and here. We have this relative maximum point at -1, 1, highest point in its general area. This relative maximum point here at 1, 1, again, the highest point in its general area. So that is the end of the review for checkpoint number 4. At this point, you should hopefully be able to understand everything and take the checkpoint, which is on my MCPS classroom. Okay, bye.